Hi everyone, welcome to Junior Cycle Higher Level. This week we're going to be doing some practical examples based on trigonometry. So we've already covered the first set of practical examples, so that we've another set now, so it's solely based on exam papers. So we're going to go through the questions and then their solutions also. So the first question I have here is 2012 paper 2 and it's question 11. So the question is to construct a right angled triangle containing the angle A such that the sine of A is 0.4. So the sine, as we know, is the opposite over the hypotenuse. So we need to come up with a solution for opposite over hypotenuse that would give us a result of 0.4. Now there's a couple of ways you could do this, but the easiest one would be 4 over 10. So if we put 4 over 10, we would get 0.4. So that would mean that 4 is the opposite and then 10 is the hypotenuse. So 10 is the hypotenuse. So now we need to draw the triangle showing that. So we'll draw a right angle triangle. There's our right angle there. We have said there that the hypotenuse in this case is going to be 10. So we put 10 here. And the opposite is going to be 4. So 4 goes here, and then your angle A is going to go there. So that's it. The next question then, find from your triangle the cos of A in third form. So I'm going to draw the triangle again and fill in what we have. So this is A. We know that 10 is the hypotenuse and 4 is the opposite. Now the cos. So we know the cos is adjacent over hypotenuse. So I'm just going to label my triangle here. So 10 is my hypotenuse, 4 is my opposite, which makes this side the adjacent. Now we don't have what the adjacent is, but we can find out using Pythagoras' theorem. So we know the Pythagoras' theorem is the hypotenuse squared is equal to the opposite squared plus the adjacent squared. So the hypotenuse in this case is 10, so 10 squared is equal to the opposite squared, which is 4 squared, plus the adjacent squared. So that's what we're looking for. 10 squared is 100, 4 squared is 16, plus a squared. So we're going to bring the numbers to one side, so it's going to be 100 minus 16 gives us a squared. So 100 minus 16 is 84. So a squared is 84, so therefore a is the root of 84. And we can leave it in the third form because it has asked us to. So we can put in adjacent there as root 84. Now, go back to the formula. So the cos of A is the adjacent over the hypotenuse. So we're just after finding out the adjacent is root 84 over the hypotenuse, which is 10. And that is the end of that question. So the next one I have is 2012, paper 2, question 13. Okay, so two vertical poles, A and B, each of height h, so we see h marked in the diagram there. They are standing on opposite sides of a level road. They are 24 meters apart. The point P on the road directly between the two poles is a distance x from pole A, and the angle of elevation from the point P to the top of the pole A is 60 degrees. So that's this angle of elevation here. Now, it asks us to write h in terms of x. Okay, so I'm just going to draw the smaller triangle because that's what we're dealing with here. So this is 60 degrees. This is h, and this is x. And they're asking us to write h in terms of x. So I'm going to label this triangle here. This is the opposite. This is the hypotenuse, and x is the adjacent. So they want x and h, so that means we're going to have to use the opposite and adjacent. So that's going to be tan. So tan of 60 is equal to the opposite over the adjacent. So tan of 60 is equal to, so the opposite in this case is h over the adjacent, which is x. Now it asks to write h in terms of x, so you want to get h on one side and everything else on the other. So if I bring the x across here, it's going to be x tan 60 is equal to h, and that's the answer. So h is equal to x tan 60. Now we can actually get the result for the tan of 60. So if you put in tan 60 into the calculator, you will get root 3. So it's going to be x by root 3 is equal to h, or h is equal to x, the root of 3 by x. So that's the answer there to that first one. So I'm going to scroll down. From P, the angle of elevation to the top of the pole is 30 degrees. Find the height of the two poles. Okay, so I'm going to draw the bigger triangle here. So we're told that the angle of elevation here is 30 degrees. We know that H is on this side. Now, if we were to get what this is here, if we look at the bigger diagram, the whole thing is 24 meters, but what we want is this part here. So if the smaller triangle is x, then the smaller part, or sorry, the part here that I've outlined, so this part here, sorry, is going to be 24 minus x, because it's the bigger bit minus x. So it's going to be 24 minus x. So we can write that in place of it. And then it's asked to find the height of the two poles. So what we can write in is the information that we have. So this is the hypotenuse, this is the opposite, and this is the adjacent. Now the two things that we have here, the information, so we have the adjacent, so it's 24 minus x, and we're looking for the opposite, so we need A and O. So A and O is going to be tan. So the tan of 30 is equal to O over A. Now in this case, it's tan 30 is equal to the opposite, which is H, over the adjacent, which is 24 minus x. So we are looking for H on its own. So we're going to bring H to one side and everything else to the other. Now if you put tan 30 into the calculator, you will get 1 over root 3. And so before we bring the 24 minus x over, let's simplify it. We figured out in the previous question that h was equal to root 3x. So instead of h, I'm going to put in root 3x over 24 minus x. So now here we can cross multiply. So 1 by 24 minus x is equal to root 3 by root 3x. And then what you're going to get is 24 minus x is equal to 3x. So now we're going to bring x's to one side and numbers to the other. So we get 24 is equal to 3x plus x. When you add 3x plus x, you get 4x. So 24 is equal to 4x. So therefore x is equal to 24 over 4. X is 6. Now, we were asked to get what h is, not what x is, but we have h in terms of x. So we got this in the previous question. So h is equal to root 3 by x. So we just fill in h is equal to, so root 3 by 6, which is 6 root 3. Now we can put that into the calculator and shorten it or break it down into meters, and it's going to be 10.39. So that's the full answer there. And that is the end of that question. Okay, so we are on to 2013 paper 2, question 1. Okay, so this question, Lean's garden is in the shape of a square. It has 4 equal right-angled triangular lawns and a smaller square patio in the centre as shown. Find the length of the hypotenuse of one of the right-angled triangular lawns. Okay, so if I split them into 2 triangles. Now before I do that, we're just going to write down, so this part here is 12, which means this part here is also 12, which means this part here is also 12, and this part here is also 12. So I'm just going to mark that in. So that's also 12. This is also 12. 12 is marked in there, and 12 here as well. Similarly, we mark in the 5s. So this part is 5. This part is 5. this part is 5, and this part is 5. So we'll just mark that into the diagram. So we have 5, 5, and 5. So we can pick any of the triangles there because they're all the same. So I'm going to pick this one here. So this is 12, this is 5, and we'll say that this is x. This is the hypotenuse. So we know Pythagoras' theorem states that the length of the hypotenuse squared is equal to the sum of the adjacent squared plus the opposite squared. So in this case, the hypotenuse squared we've said is x squared is equal to the adjacent squared, we'll say is 12, plus the opposite squared, which is 5. So x squared is equal to 12 squared is 144, plus 5 squared, which is 25. So x squared is equal to 169. So therefore x is the root of 169. So x is 13. And it's meters. So the next part of the question, find the area of one of the triangular lawns. So find the area of one of the triangular lawns. So we need to find the formula for area of a triangle. So area of a triangle is equal to half the base multiplied by the perpendicular height. So again, I'm going to draw the triangle. So this is 12, this is 5, and we've now figured out that the hypotenuse is 13. So the area of this triangle is half the base, that's going to be half of 12, by the perpendicular height, which is 5. You can literally put that straight into the calculator, and you'll get half of 60, which is 30. So it's 30 meters squared is the answer to that one. Okay, so the next question then, find the area of the square patio in the middle. Okay, so I'm going to draw the square patio. So the square patio looks like this. We have figured out there that each of the hypotenuse is worth 13. So that must mean that this side is 13, this side is 13, this side is 13, and this side is 13. Now, area of a square is the length multiplied by the width. So in this case, it's going to be 13 multiplied by 13. When you put that into the calculator, you get 169, and it's meters squared. Okay, so we'll go on to the next part of the question. So part D. The patio is to be paved with rectangular flagstones of length 80 centimeters and width 50 centimeters. Calculate the number of flagstones that Liam needs to buy in order to cover the patio, allowing an extra 20% for waste. Okay, so the first thing we do there is draw a quick sketch of one of the flagstones. So it's a rectangular shape, which it has stated. It has told us that the length is 80 centimeters and the width is 50 centimeters. So that's one flagstone. Now, because we've been dealing with meters, we should really convert these centimeters to meters as well. So 80 centimeters in meters is 0.8 and 50 centimeters in meters is 0.5. So the best thing we can do here is get the area of one flagstone. So the area of one flagstone. So that's going to be the length multiplied by the width. And again, we're working in meters here. So the length of the length is 0.8 meters multiplied by the width, which is 0.5 meters. Now plug that into your calculator and you'll get 0.4, and it's meters squared because it's an area. Okay, what we're being asked here is to calculate the number of flagstones that Liam needs to buy to cover the patio. Now, we've just figured out that the area of the patio is 169 meters squared. So we need to get 20% of that because it says to allow for an extra 20% of waste. So we need to get 20% of 169. So the way we do that is we multiply 169 by 0.2. So plug that into the calculator, you'll get 33.8 meters squared. So we need to add that on to the area because it has said extra 20%. So it's 169 meters squared plus 33.8 meters squared. So plug that into the calculator. That gives us 202.8 meters squared. So that's the area that we're dealing with. So 202.8 meters squared. So we want to see how many flagstones we need to cover that area. So we already have the area of one flagstone. We got it to be 0.4 meters squared. So the total area, which is 202.8 meters squared, divided by the area of one flagstone, which is 0.4 meters squared, and that will give us the number of flagstones that we need. And you plug that into the calculator, you get 507 flagstones. So 507 flagstones. So that's it for that question. Yep, so we're on to the next one now. So we're on to 2013, paper 2, question 10. So in the triangle ABC is shown on the diagram. The length of AB is 2, so I'm going to mark that down. So the length of AB is 2. The length of BC is 1. And then it asks us to find the length of AC and give your answer in third form. So we're going to have to use Pythagoras' theorem here. So I'm going to mark onto the diagram. So this is our hypotenuse because it's opposite the right angle. I'm going to put 1 as the opposite, and we'll call AC the adjacent. Okay, we are being asked to find what AC is, so we need a formula with the adjacent in it. And I'm going to use, I can use either of the other two sides. I'm going to just choose to use the opposite side here. Now you can do it this way, or you can use Pythagoras, but I'm going to do it this way. So, actually just realising now we can't use Pythagoras, and this is actually a very common mistake because we've no angle. So because we know angle, we have to use Pythagoras. So I'm going to get rid of what I had there. So this is 1. So we can still leave in the markings hypotenuse, opposite and adjacent. So the rule for Pythagoras is the hypotenuse squared is equal to the opposite squared plus the adjacent squared. Okay, so in this case our hypotenuse is 2, so it's going to be 2 squared is equal to the opposite squared, which is 1 squared, plus AC squared. So 2 squared is 4, is equal to 1 squared is 5, or sorry, 1 squared is 1, should I say, plus AC squared. So we need to bring numbers to one side and letters to the other. So 4 minus 1 is equal to AC squared. So 3 is equal to AC squared. So AC, in this case, is going to be the root of 3. So I'll just put that into the diagram. So we found out that that side now is the root of 3. Okay, write the cos of BAC and hence find the angle BAC. Okay, so first of all, cos of BAC is going to be, so A over H, that's the rule called a herring. So cos of BAC is A over H. So the angle BAC is this angle here. Okay, so the cos of the angle BAC is the adjacent over the hypotenuse, so that's going to be root 3 over the hypotenuse, which is 2. Okay, so if that's what the cos of BAC is, to get the angle BAC, we need to bring the cos underneath the equal sign, so it becomes cos minus 1 of root 3 over 2. Now you can put that straight into the calculator, and the angle BAC is 30 degrees. Let's just have. So that's your answer to part B. On to part C now. Sketch a right-angled isosceles triangle in which the sides are the equal sides are 1 unit each, and use it to write the cos of 45 degrees in third form. Okay, so we need to draw a right-angled isosceles triangle. So I'm going to draw it this way. So this is my right angle. So I'm going to make these two sides the same. So I'm going to say they've told us that that's 1, those equal sides are worth 1. And they're telling us then to write the cos of 45 degrees in third form. So what we need to do here is find the length of the third side, which is the hypotenuse. So this is the hypotenuse. And we'll say this is the opposite and this is the adjacent. So we're going to use Pythagoras' theorem here. So the hypotenuse squared equals the opposite squared plus the adjacent squared. So equals the opposite squared plus the adjacent squared. Now we can just fill in what we have. So we don't have the hypotenuse, but we do have the opposite. So that's going to be 1 squared plus 1 squared. So the hypotenuse squared is equal to 1 plus 1. So if the hypotenuse squared equals 2, then the hypotenuse is equal to root 2. So this is root 2. Now I'll do the cos over here. So cos is A over H. So the cos of 45. So the cos of 45. So I should mention that each of these are 45 because it's an isosceles. So the cos of 45 is a over h. So a in this case is 1 over root 2. And that's the answer to that part. Okay, next part is show that the cos of 75 degrees is not equal to the cos of 45 plus the cos of 30. So all we have to do here is get what the cos of 75 degrees is. So if you literally type cos 75 into the calculator, you will get 0.2588. And then what we're going to do is get the cos of 45 plus the cos of 30. So again, type that into the calculator. So the cos of 45 when you put it in is going to be 0.7071 plus we're going to get the cos of 30, so it's 0.8660. When you add them together, you get 1.5731. Now, that answer is not the same as that answer. So you've just proved that 0.2588 is not equal to 1.5731. So we usually write QED, which means you've proved it. So that is the end of that question. So the next one now is 2014 paper 2 question 6. Okay, so this question, it says to construct a right angled triangle ABC in where the length of AB is 6 centimeters, the angle ABC is 90 degrees, and the length of AC is 10 centimeters. Okay, so you're going to start by measuring AB, which is 6 centimeters, and I'm just going to draw it here. This isn't drawn to scale, but you use your ruler. So this is A, this is B, and this length here is 6 centimeters that you've been instructed to do so. So then what you're going to do is you're going to use a protractor to make a 90-degree angle, and you're going to draw a line straight up as shown. So you use obviously a ruler for this. So this is 90 degrees. Okay, so it's saying that AC is 10 centimeters. So what you're going to do is set your compass to 10 centimeters. So you measure 10 centimeters on the compass. So you're going to set your compass to 10 centimeters. Then what you're going to do is you're going to put the pin of the compass on point A, and you're going to measure, so it's already measured at 10 centimeters, and you're going to extend out the compass until it makes an arc with the line that you've drawn from the right angle. That point there then is going to be C. Then you get your ruler and you join up like so, and that is the length of AC. So that's 10 centimeters. Okay, so that's the first part of the question done. On your diagram, measure the angle CAB and give your answer correct to the nearest degree. So the angle CAB is going to be this angle here. So you're going to get your protractor because it says to measure the angle. So it says to measure the angle, you're going to get your protractor. So you're going to put the base of the protractor at A, and you're going to measure what angle this makes here. Now when you do that, you're going to get 53 degrees. So that angle there should be 53 degrees. Okay, so part 3, let x be the whole number you wrote as your answer to part 2. Use a calculator to find the cos of x. Give your answer correct to 3 decimal places. So x is the number that we found in part 2, which was 53, so it's going to be the cos of 53 degrees. Now it says correct to 3 decimal places. So when you put that into the calculator, what you will get is 0.6018. Now correct that to 3 decimal places. So when you're rounding to 3 decimal places, this is the number you're going to round. So you look at the number after it, which is 8. 8 is greater than 5, which means you're going to round the number 1 up. So it's going to be 0.602. So then the last part is part 4. Jacinta says that the cos of CAB is exactly 0.6 because the cos of CAB is equal to the adjacent over the hypotenuse. So explain why your answer in part 3 is not the same as Jacinta's. So for this one, the angle CAB is going to be the cos minus 1 of 6 over 10. Now, you put that into the calculator, you will get 53.1301 degrees. So the answer here is if x is a whole number, then the cos of x can never be exactly 0.6. So it can never be exactly 0.6. So that's the end of that question. I think we have time for one more. I'm going to go down to a more practical based one. Yeah, so this is 2017 paper 2 question 8. Okay, so the diagram below shows two right-angled triangles. We've the triangle ABC and the triangle ACD. They have right angles at B and D respectively, and you can see them marked in there on the diagram. So the length of AB is 10, the length of AC is 12, and AD is equal to DC. So AD equals DC. I'm going to mark that in. So AD is the same length as DC, and they've actually marked it in as X. So they're the same. So it's an isosceles. Okay, use trigonometry to find the size of angle Y and give your answer correct to 1 decimal place. So I'm just going to draw out the triangle with Y in it. So it looks like this. This is your right angle, this is 10, this is 12, and we're looking to see what Y is. So we're going to mark in what we have on the diagram. This is the opposite, this is the hypotenuse, and this is the adjacent. So we need to use what we have. So the unknown is the angle, so we need to use adjacent and hypotenuse. So it's going to be cos. So the cos of Y is A over H. So the cos of Y is equal to 10 over 12. So to get what Y is going to be Y is equal to the cos minus 1 of 10 over 12. Now put that straight into the calculator, correct it to 1 decimal place, and you'll get 33.6 degrees. And then we have to find the value of X correct to 2 decimal places. So X. So I'm going to draw out that triangle. So what we have is this. So this is X, and this is 12. Now, have we any other? No, that's it. Okay. Now, also this is a right angle, which would make 12 the hypotenuse. So we'll say that this is the adjacent, and this is the opposite. Now, we can use Pythagoras' theorem here. So it's the hypotenuse squared is equal to the opposite squared plus the adjacent squared. So the hypotenuse squared is going to be 12 squared is equal to x squared plus x squared. Now when you add x squared plus x squared, you get 2x squared. So 144 is 12 squared is equal to 2x squared. Okay, so then we're going to bring the 2 underneath. So 144 divided by 2 gives us x squared. 144 divided by 2 is 72. So x squared is 72, which means x is the root of 72. Now you can put that straight into the calculator. So the root of 72 will give you 8.49, and that's correct to 2 decimal places. So that's the end of that question. I will attach some extra links to some extra video tutorials and exam papers and marking schemes, so I recommend that you follow them as well, just for some bonus material. And I will speak to you next week.